Hi everyone, welcome back to Life Technologies YouTube channel and thank you for watching. So this is a continuation of our Huawei Lab simulation series, and in this episode we'll be discussing how to implement in the ASBGP MPLS IPVPN option B on Huawei routing devices. So remember, in our last two episodes we have discussed how to implement the ASBGP MPLS IPVPN option A on Huawei routing devices, and we have also demonstrated how the packet forwarding happens all the way from the local CE to the remote CE. So just a recap, option A, we don't use MPLS between the SBR, we just use the normal IPv4 routing between the SBR. So we don't configure any MPLS configuration on interfaces between the SBR. So the SBR sees the peer SBR as a CE, and the SBR has to handle all the routing information from the customer. So this one places very high requirement on the SBR. It should be a high-end device that has the ability or the capacity to handle and process all the customer routes. Another thing that we have mentioned is with option A, it's not scalable enough. Remember, a service provider network normally has many services. We will have many customers, and it's normally segmented into different autonomous systems. Maybe you could have different regions, 5 or 6 or even 10 regions, and then you need to ensure that you have connectivity between these regions. So with option A, it means you need to configure the VRF to VRF peering between all the SBRs in the network. And you also need to do the VPN instance configuration on the SBR. So this is not scalable enough for a big service provider network. So it's limited because of its scalability. So that's why we have another option. We call it the option B. So option B is much more simpler and it's scalable compared to option A. So before you watch this option B, remember you need to go back and watch option A video and try to understand how the configuration are, and even try to do it in the lab. If you have any question, feel free to reach out. And once you are now familiar with option A, you can go ahead and watch this video for a better understanding. So this is the topology that we are using. The same topology we used for option A is the same topology that we are using for option B. So we need to evolve it from option A, and then we evolve to option B. So this is the setup. We have two autonomous systems for the service provider. We have AS200. In AS200 we have provider edge router 1, provider router 1, and SBR1. So SBR, I've mentioned, it's the autonomous system border router or boundary router. In this autonomous system 200 will be using ISIS as our IGP, so we need to ensure that we have connectivity within the autonomous system, so we choose to go with ISIS. You can still go with OSPF, you can use RIP, ARP, depending on the requirements. And then we will be doing BGP configurations between the PEs and the SBR in this autonomous system 200. So we also have autonomous system 100. And in this autonomous system 100, we are using OSPF as our IGP, so that one doesn't affect. You can use ISIS in one AS, you can use OSPF in another AS. Remember, they don't interact. So in this AS, we have three routers also. We have SBR2, provider router 2, and then we have provider edge router 2. So we have the customer devices. We have customer 1 and customer 2. So customer 1 and customer 2, they are in VRF1 and they need to communicate. And then we have customer 3 and customer 4, which they are in VRF2, and they also need to communicate over or through our service provider network. So for option B, we'll be configuring VPN peering between the SBRs. And then we need to enable MPLS on the interfaces between the SBR. So this is the main difference between option A and option B. In option A, we are just doing IPv4 routing between the SBR. and we configure VRF to VRF BGP peering session. But with option B, we are configuring VPN v4 peering session between the SBR, and then we are also enabling MPLS between the SBR. So the packet that is transported between the SBR will also have a label. Remember, for option A, we didn't see any label when we did a demonstration of how the packet flows from C1 to C2. So the objective is to ensure that we have connectivity between the different customers in the same VRF. So C1 should be able to communicate with C2, and C3 should be able to communicate with C4. And all these customers, they are in different autonomous systems. As indicated, we have a 65,500 for C1, 65,000 for C2, 400 for C4, and 300 for C3. So for us to be able to achieve the objective of this lab, we need to configure some protocols. First is the IGP protocol that we need to configure. Remember, I mentioned that we are using OSPF for S100 as our IGP, and then we are using SIS in S200. We also need to configure BGP sessions. We are also using BGP as our PECE protocol, so we need to configure BGP peering session between the PEs and the CEs. We need to configure MPLS and LDP. Remember, we are using label switching, so we need those labels distributed across our network. So this is the topology that we are using, same as option A. So before we go into the lab, we first need to understand some basic features or key features of option B. So the first feature is that it's more scalable and easy to configure compared to option A. So remember, we are not doing VRF to VRF peering as before. If you have 10 VRFs in option A, you need to configure 10 BGP peering sessions between the SBRs. But in this case, with option B, we are not configuring the BGP peering sessions, the VRF to VRF BGP peering session between the SBR. We only implement VPN v4 peering session. So it's very scalable because you don't have to configure the VRFs on the SBR. And then you also don't need the sub interface. You don't need to configure so many sub interfaces or physical interfaces between the SBR. So it's more scalable and easy to configure. And then route targets are globally significant. So with VPN targets or the route targets for option B, you need to ensure that they are globally significant. So if you configured a VPN target on P1, the same VPN target should be configured on P2 because it's globally significant. If you don't, then it will impact the export and import of routes. So normally we use the same VPN targets for P1 and P2 in the different autonomous systems. Then another feature is that we are running MPLS between the SBRs. So I've mentioned that we need to configure MPLS between the SBR for us to be able to route traffic. Then for the BGP peering session, we are configuring VPN v4 peering sessions between the SBR. Remember, with option A, we configured VRF to VRF BGP peering. Then with option B, also another thing to mention is that we don't configure VRF configurations on the SBR. VRFs are only configured on the PEs, so we don't need to configure VRFs on the SBR. We don't configure VPN instances any on the SBR. We only configure them on the PE router, the provider edge routers in different autonomous systems. And the final thing to mention is that SBR will accept all the VPN v4 routing information without VPN target filtering. So given that we are not configuring VPN instances on the SBR, then we need to disable the VPN target filtering. Remember, if you configure VPN target filtering, then this router has to have the VPN instances for it to be able to accept the routes. So we need to ensure that we disable VPN target filtering on the SBR. So these are just the key features of MPLS VPN option B. So we can now move to the lab. Of course, for the lab, majority of the configuration are similar to option A, but we will just go through them just so that you are familiar. But remember, again, you need to watch the last two videos on option A before you can watch this video on option B. So the configuration steps, the first step is that we need to configure system name and interface IP addresses in S200. So we configure the system name and the interface IP addresses. And these are the configurations for SP1, P01, and SBR1. So we can verify that these configurations are in place. I can log into P1. On P1, and do terminal monitor. Display IP interface brief. You can see that we have IP address assigned on these interfaces. On SBR, it's the same. Display IP interface brief. We have IP addresses assigned on the interfaces. And we have also created loopback 0 on these routers, just to be used for BGP and also for LDP. So that is the first step, just basic configuration of configuring the system and the IP address on interfaces, both logical and the physical interfaces. So step 2, we need to configure IGP in S200 and test reachability between different nodes. So this is similar to option A. We are configuring ISIS process 20. We are using IS level 2, and cost style is set to wide. The network entity is generated from loopback 0 IP. Then we also configure the sysname, the IS name for this case. Then we enable our ISIS on interfaces, loopback 0, and the interface connecting to P01. So these are the configuration. On P01, we do the same. We create ISIS process 20, configure IS level, cost style to wide, network entity, and then the IS name, and we configure it on the interface. So for SBR2, it's the same. So we can verify that our ISIS protocol is running okay, and we are able to ping different loopback IPs from one router to the other. So from here, I can display ISIS peer, ISIS interface first. You can see that we have these two interfaces with ISIS running. Can display ISIS peer. We have one peering session to P01. I can display IP routing table, and we have ISIS routes coming in. So I'm sure I should be able to ping the loopback of our ASBR. Remember, we'll be using the loopback to establish BGP peering session between the routers. So you can see that our IGP is running okay, and we can be able to reach the other devices. So on P1, I will display current configuration ISIS. These are the configuration for ISIS as we have seen in the PDF. Then I can display ISIS interface. We expect to have 3 interfaces, the physical interface and the loopback interface. Then display IP ISIS peer. We have 2 peering sessions to provide a AG1 and SBR1. Then if I display IP routing table, we also have routes learned via ISIS. So on SBR, we'll do the same, display ISIS peer. We have 1 peering session to P01 that is up. Display IP routing table. So we have the routes coming in from ISIS. We can try to ping the loopback IP of P1. So our IGP is running okay, so we can move to the next stage of our configuration. The next stage of our configuration is that we need to configure MPLS and MPLS LDP on all routers in S200 and enable it on the interface. So similarly as we have done in option A, we need to configure the LSR ID, enable MPLS and enable MPLS LDP. Once we have done this, we can now enable MPLS and MPLS LDP on the interfaces. So these are the configurations on P1, P01 and SBR01. So we can verify that our LDP sessions are okay. We log into P01, display MPLS LDP session. You have two LDP sessions to P1 and SBR1. We can also display MPLS LDP LSP just to ensure that we have LSP information. We can display MPLS LDP interface. We have these interfaces enabled with the MPLS and LDP. So this one verify that our MPLS and LDP is running okay. We can verify the sessions on SBR1, display MPLS LDP session. We have one session to P01. On P1, we also expect one session. MPLS LDP session, we have one session to our P router. So once we have configured our MPLS and LDP and verified it's okay, we now need to start configuring BGP peering sessions between P01 and SBR01. So for the BGP peering session, it's the same. We are configuring VPN v4 peering session between the two routers, P01 and SBR01. So this is similar, it doesn't change, it's the same as the one we used for option A. So we are just configuring peering session between the two routers using loopback IP. This is IBGP, so we can use the loopback IP to establish the peering session. So I can verify that our BGP peering session is up. I can display BGP VPN v4 all peer. You can see that we have a peering session to 4.4.4.4, which is SBR1. So this one confirms that our BGP configurations are okay. Remember, these are the configuration. We are doing VPN v4 peering between the two routers. The next step is to configure interfaces of all routers in S100. So we have finished configuring the basic setup for S200. We need to do the same for S100. So the first step is to configure interface of all routers in S100. These are the configuration. We configure the sysname and assign IP addresses on the interfaces. On gig 00, the interface connecting the SBR, we are configuring the IP address on the physical interface. Remember, with option A, we had to configure sub-interfaces and assign different IP addresses on each sub-interface for a different VRF. But with option B, we only need to configure one IP address between the two. And that is it. It will be able to serve the purpose. So on P02, we do the same. Just configure interface IPs. This is on P2, we do the same, so we can verify our configuration. Can display IP interface brief. You see that we have these IP addresses configured. On P2, display IP interface brief. We also have IP address configured and the loopback IP is also up. On P2, display IP interface brief. We have IP addresses configured on the interfaces. So this verifies that our configuration, our basic configuration for the interfaces and the sysname is okay. So the next step is now to implement IGP. Remember, in S100 we are using OSPF as our IGP. We can still use SIS, same as the one that we have used in S200. They don't interact, so there is no problem with that. So we configure OSPF in S100. We need to advertise the networks for loopback IP and the interconnected interfaces. So these are the configuration that we are using. OSPF, then we use the network command to advertise the different network that we need to be advertised in our OSPF domain. So we can verify that our OSPF status is up on SBR2, can display OSPF interface. We have the interfaces, two interfaces, display OSPF peer. We have one peering session from SBR2 to P02. So you can see more details about it, the neighbor, IDs, authentication, sequence, which one is the DR, which one is the DR, which is the state is full, the router ID, and many other, the timer, the dead timer, the hello timer. All this information you can see when you run the display OSPF peer. So on P2 we expect to have two sessions, display OSPF peer. We have two OSPF sessions to SBR2 and P2. I can display IP routing table to verify that we have OSPF routes. We have them coming in. On P2, can do the same, display OSPF peer. We have one peering session, display OSPF route. We have routing information learned from OSPF. So I should be able to ping 5.5.5. I can also ping 6.6. Those are the loopbacks for SBR2 and P02. So once we have verified that our IGP is okay, we are now ready to go ahead and configure the BGP peering session. I mean, we need first to configure the MPLS and MPLS LDP on all routers in S100. So the same way we have done in S200, we also need to configure the MPLS on the other AS. Remember, we have also to configure MPLS on the interface connecting the two SBR. So you can see that on this interface, we are enabling MPLS on the interconnect interface between the SBR. Then, of course, you always have to configure the LSR ID before you enable MPLS. So the configuration are similar, just that we are now configuring MPLS on the interface between the ASBRs. So these are the configurations. And we can verify that our MPLS sessions are up. Display MPLS LDP session. We have two sessions, to 5 and 7. Display MPLS LDP. We also have one session on P1, P2. On SBR, we can also verify that we have MPLS LDP session. We have a session that is operational. Display MPLS LDP LSP. We should be having the LSP information. On P2, we can also display MPLS LDP LSP. We'll have the LSP information on this router. So once we have finished configuring MPLS and LDP, the next step is now to configure BGP peering session between SBR2 and P02. And we also need to verify the status. So the configuration are the same, no change as of the configuration of option A. So we are just specifying the configuration, the BGP peering session between the two routers, SBR2 and P02. So the configurations are similar to the ones we have used in option A. So we can verify that our session is up. Display BGP VPN v4 all peer. We have a peering session to 7.7.7. Display BGP VPN v4 all peer. We have a session to 5.5.5. So our BGP peering session, the VPN v4 peering session between the PEs is up. So once we have configured the BGP peering session between the PEs, the next step is now to configure VPN instances on PEs. So this one is a miss. We don't need to configure BGP sessions, the VPN configurations on the ASBRs. So we are only configuring this VPN instances on the PEs. And remember, they have mentioned that the VPN target are globally significant. So we need to ensure that we are configuring the same VPN target, the export and import, just to ensure that we are able to exchange the routes between the two routers. So these are the configurations on PE01. And then we also need to configure on PE02. So once we have configured, we can verify that we have it. So when you run this command, display current configuration VPN instance, you can see that we have the VRFs configured, VRF1 and VRF2. I will do the same on PE2. So you can see we have similar configurations for the VRF1 and VRF2 on PE2. So we need to ensure that the VPN targets for the VRFs, for the same VRFs are same, so that we don't have issues with route import and export between the PEs. So we haven't done any VRF configurations on the ASBR. So once we have configured the VPN instance, the next step is now to configure our BGP MPLS VPN option B on ASBRs. So remember, I mentioned that on the SBR we are configuring a VPN before peering. So we don't configure the VRF to VRF peering session between the SBR. Instead, we configure the VPN before peering. So they'll be able to exchange all the routes. The SBRs will be accepting all the routes from the peer SBR. And another thing that I need to mention is that when you are configuring the VPN before peering between the SBR, you need to remember this command to undo the policy VPN target. So remember, the SBR doesn't have any VPN instances configured. So if you configure the policy VPN target, it means it will be filtering routes based on the VPN targets. And no routes will be learned between the SBR because we don't have any VPN instances configured on the SBR. So you always have to undo the policy VPN target command for it to be able to accept all the routes from the SBR and advertise them to the PE. Then the PE, they want to do the VPN target filtering and install different routes into different VRFs. So these are the configuration. The only thing you need to pay attention to is undo policy VPN target on the SBR. So we can verify that our peering sessions are up between the SBR. We can display current configuration BGP. So you can see that here we have the command undo policy VPN target. And then if I do display BGP VPN v4 all peer, we have a peering session to 172.16.16.3. So on SBR2, we can verify the same, display current configuration BGP. We have the undo policy VPN target command. Remember, this is to allow the SBR to accept all the routes without checking the VPN targets. And then we can verify the peering status, display BGP VPN v4 all peer. So we have a peering session to 172.16.16.2 and it's established. So these are the VPN option B configurations, just the normal VPN v4. The next step is to configure in customer-facing interfaces on PEs in S100 and 200. So we are configuring the customer-facing interface, and we need to bind the VRFs on the PEs. So remember, on P1 we have two customers, C1 and C3. So we need to configure these two interfaces facing the customer and bind the VRFs and also configure the IP addresses. So we do the same on P2. We have two customers, one in VRF1, another one in VRF2. So now on PE, I can display IP interface brief. We have these interfaces configured. We have 10.10.10.2. This is for the VRF. Then we also have 30.30.2. So these interfaces are configured with IP addresses. I can display current configuration. Interface gig 0/0/0. We have bind the VRF1 and assign an IP address. We can see .2. We have bind the second VRF, VRF2, and assign the IP address that is allocated. So once we have done that, we now need to configure BGP peering session between the PEs and the CEs. Remember, we are using BGP as our PE-CE routing protocol. So we need to configure these peering sessions between the PEs and the CEs on the PE. So the PE, we are configuring the peering session within the VRF. So we create one under VRF1 and another one under VRF2. So once we have configured these BGP peering sessions, the next stage is to now configure the CEs and verify that we have connectivity between CEs in the same VRF. So these are the configurations on the CEs. We configure the sysname, we configure the interface facing the PE and loopback IP that will be used to simulate customer device, and then we configure BGP peering session, just the normal unicast peering session towards the PE. And we are advertising this network so that we can be able to test our connectivity. So on customer 2, we do the same. Configure sysname, configure interface IPs, and then configure BGP and advertise this network in our BGP protocol. So similar configuration on the CEs, we haven't changed anything. The configuration for the CEs are similar to the ones we used in option A. So again, if you have missed that video, remember to check out the video on option A. We did the configuration step by step, so it will be easy to follow up. And then we also have a video showing how the packet flows from the CE, from the local CE to the remote CE. So that one will help you in better understanding option A before you transition to option B. So these are the configuration. We can verify that our peering sessions are up. The BGP peering session, display BGP peer. You can see that on C1 we have a peering session established towards the PE. On P1 we can also verify by running the command display BGP VPN v4 all peer. You can see that we have a peering session. We can verify on C4 display BGP peer. We have a peering session established. On P1 we can also check the routing table, display IP routing table. On the global routing table we don't have any VRF routes. If we want to check the VRF routes, we need to add the VRF. So it's VRF1. We have routes learned from VRF1. We can check VRF2. We also have routes learned from VRF2. So this is on PE. Once the PE has learned routes from the CE, it will propagate the routes to the SBR. So on the SBR, remember we don't have any VPN instances, so we can run display BGP VPN v4 all routing table, and we can see that we are learning these different routes and they have been accepted with the they have been accepted on the SBR. So we have learned all these routes. And if I display BGP routing table, I need BGP VPN v4 all routing table 1.1.1. You can see that this route has come in with an external community RT of 200:1. If I check 8.8.8, it still have the same route target. So the SBR has accepted these routes without checking their route targets, because we have disabled the route target filtering on the SBR. So on SBR2, we can also verify that we have display BGP VPN v4 all routing table. We have the routes on the SBR and they have been installed in the routing table. On P2, we can also display IP routing table, VPN instance, VRF1. So we have the routes. On VRF2, we also have the routes. So on CEs, we can also check the routing table, display IP routing table. We have learned this loopback from CE2. So we are able to get the route from CE2. Then we can do a ping minus A. I will source the loopback IP that we have advertised, 8.8.8.8. So this one confirms that we have communication between the two routers. On VRF2, we can also verify that we have the route, display IP routing table. We have 9.9.9 and 10.10.10. So if I ping minus A 9.9.9, we are pinging 10.10.10.10. We are able to ping. But if we try to ping 8.8.8, we should not be able to, because they are in different VRFs. So we have separated the traffic from different customers using the VRFs and isolated them that they cannot communicate through our service provider network. So remember, we've mentioned that it's very easy to evolve from option A to option B. You just need to do some few changes on your network. The first thing is that instead of IPv4 routing, we are now doing VPN v4 peering session between the SBR, and then we need to enable MPLS on the interface between the SBR. So if we were to disable MPLS on this interface, our services will not be able to flow between the SBR. So we can illustrate this. I will do a continuous ping from C1 minus C. I will do 100 packets. I need this. C 100. So we are pinging through, no problem. On the SBR, we'll disable the MPLS on the interface. So we need to verify which interface. You can see that our ping is still going through, but now on the SBR, I need to disable MPLS on the interface between the two SBR. I will undo MPLS, and on C1, you can see that we are now not able to ping between the two routers. On C1 again, we can verify whether we have the route, display IP routing table. So we don't have the route because we have disabled MPLS between the two. So this one I will configure back MPLS and continue our ping, and we should be able to get the route and also to ping through. So we have the route, I can ping again, and I'm able to ping without any issue. So with option B, we just need to ensure that we have MPLS configured between the SBR, and we do VPN v4 peering between the two routers. And one key thing that we need to remember is to disable VPN target filtering on the SBR so that they will be able to accept all the routes. So guys, thank you for watching. This is it for this option B implementation. And the same way we did for option A, we'll also be demonstrating how the packet forwarding is done with option B. So that will be our next episode, just to demonstrate how we are doing the label switching on these between these autonomous systems. So if you have any question, feel free to reach out, and if you require the script and the topology, you can also reach out to me on LinkedIn, and I should be able to share with you. Thank you for watching again, and please remember to subscribe to our channel and stay tuned for more upcoming videos. Thank you.